Hey guys, hi, it's Shravan here. I would like to start this video by saying why is not programming a sport. Okay, fun is enough. Let's do this. Okay, let's start. So guys, I'm using PyCharm editor here. I'll create a new file and maybe this is just a linear regression program using Tensorflow. So let's start importing all the libraries that are required for this problem. So as recently I did a certification on this Tensorflow, and really, believe me guys, I really feel very good about it. I think everyone should do this. Okay, so sure. And yeah, in this thing I have already stored the dataset in the GitHub repository. So that is a graduate admission .csv. So we need to use the raw link that is provided by the GitHub in order to load in the pandas data frame. So let's create a data frame. Pandas .csv URL. Yeah, and let's print out the first few lines of the data frames. Yeah, so here we will be actually determining the chances of admission for a student to get admission in a particular university given GRE, TOEFL, university rating, SOPL or CGPA, research or not thing. So here target is as stated, admit, like we'll be actually determining possibility of admissions, getting admissions in a particular university. And here I think your research column is kind of categorical, so I'll be considering research column to be categorical. So let me just define the categorical columns. Categorical columns. Yeah, categorical column. That is here in this case it's research. Let me just copy to avoid spelling mistakes. I'm really very bad at it. So now let's not encode it using again pandas to get dummies function. I think they should be familiar with the data machine related stuff like and again after doing that, let's print out the first few lines. Okay, so here you can see research 0 and research 1 column has been added. Wherever it was 1 it will be like 0 1, and then if it is 0 then it will be 1 0. That is encoding that will be done here by pandas. And now let's separate out the data into train and valid dataset. So we will be doing the sampling, and we'll actually sample it out to 85% and 15%, 85% data for training datasets, and 15 rest of the data will be treating it for validation. So drop all the train data frame index, so we'll get the valid data frame. Okay, now let's separate out the labels from the data. Okay, removing the labels from the data sets. Okay, data train labels. Now let's pop out the target column. Target, and then store only the values. Okay, values will actually give back numpy array. Now valid labels, valid data frame, repeating the same thing, pop target values. Yeah, okay, now separate data into is done. Moving labels. from the free data. Now maybe next step is to converting data frame to numpy. Okay, train data. No, I think yeah, let's scale the data before we actually convert it into numpy. Now let's take the stats. We will actually do the normalization step using only train dataset, so that comes under the data leakage concept. So we will scale both the data with only training datasets data. Okay, and the normalized train data frame is equal to, we'll just subtract the mean and divide it by standard deviation. This is the simplest way. Why I use this method, it's like we can store the mean and the standard deviation for further usage. That is why I think this is the simplest and the effective way of normalizing the data set. Stats and standard deviation. Stats, okay, sorry. Okay, now yeah, train data, I will just convert it into numpy arrays. I'll tell you why this is done. Starting numpy array, and yeah, now let's just take first value in the training results for the future testing. Once the model is trained, we'll just try to predict and find out the values, if it is predicting properly or not, but from checking the validation data. This new access is just to add up one more level to the array, like it will just increase one dimension of an array to two-dimensional array. We'll just print out the first data and then print out the results. Okay, yeah, this is the thing you can see here. 0.71 is the result that we are, or the above set of array. As you can see in the, like in this, it's two-dimensional array, and p.newAccess will actually do that part. And now let's convert it into numpy array. Valid data, normalize valid data to numpy, yes. And now we'll actually create a function to convert it into Tensorflow datasets. So this is why I actually converted the data frame into numpy array. So let's call the function as prepare datasets, and this I'll tell you where the performance actually, which step actually increases the performance. Prepare datasets, data, will pass data, labels, batch, and shuffle buffer. This shuffle buffer will actually just shuffle the data from certain data, from certain length of datasets. So that will specify it in this shuffle buffer. So dataset, we create it using the t of data on dataset, and here we'll pass in a tuple with data and labels, and then we'll just shuffle the data with the shuffle buffer that we pass in, and then we'll create a batch of certain batches, like train 30 batches at a time, like that also. And then prefetch will actually prefetch the next upcoming batch, so that the training loop may not have to wait further while it has done training. Sorry. Now let us create training dataset. by using the above defined function by passing the train data, labels, and again the batch size. Okay, we have not defined it yet, let's define it now. Batch size, let's keep it for 32 to 32. Buffer, we'll keep it 100. Now again we'll repeat the same for the validation dataset. Prepare dataset, valid data, valid labels, batch size again, buffer. Okay, I think we are done with the data preparation stuff. Now we'll go to building a simple neural network model. So Tensorflow, Keras, we'll use Keras again here. It's actually the best and simplest way for creating a neural network here. So Keras layers, we'll use dense layer. We will take 128 activation value which removes out all the negative values. We'll create another layer. It's basically your choice, how much ever you want you can put it in. Then we'll add one last layer to with only one unit to actually give the prediction value. Compile, let's compile it, and we'll store the history of training loop. Model.fit will actually train it. Model.compile, let's compile it by specifying loss and optimizer function. For this linear regression, I will use MSE loss function. Optimizer, let us use SGD. This is the best two combination I have seen so far. And then last but not least, metrics. So we'll use accuracy. Then fit, we'll have to train that model with training dataset that we just created it above using prepared dataset function. We'll just train it for 10 loops. Validation dataset, we'll pass it here. Now let's just do a sanity test if it is working fine. Oh no, something is wrong. Line number 55. Let's take a look at it. Okay, nothing is wrong here. It is fine. Let's go to prepare dataset function. Okay, sorry. I think dataset dot from TensorFlow slices. Okay, I missed it. Now let's run it again. Okay, cool. Everything is running fine. I think accuracy will not be having not get any idea from that. So we'll just use MA here. Okay, as you can see, the values have dropped, giving us an indication that it's working fine. Now let's just plot this curve, the training curve. So that will give you again like confirmation, like that you are going on a right track. So let's work around for plotting. So as we can see above, like storing history from the model training. From that we can actually get all the training updates. So we'll take the MAE from that updates, and then validation MAE. This is the for the validation dataset validation loop that it runs, and then we'll plot it. We'll define epochs, so we'll actually plot the graph like MAE against epochs. So this for each epoch, so what is the MAE or validation MAE, like that kind of plot will do. Plotting, just take okay, and then now let's plot it. Figure, just keep some size. We always go with this size when it gives good look. Plot box and then MAE, box against MAE, and label, give some label, training MAE, and now we'll also plot validation loop also in this, so we'll get an idea if there is any overfitting as such. problem that this gives us a very good idea by plotting both training and validation loop together. Dot null, also legend to it. Sure. Okay, now I'll also do plotting for the losses. So again, I'll give some good idea about like how the loss is, whether the loss is decreasing or not. Again, the validation history, val loss. Now we'll plot it. Plot figure will give the same size as we again above. That is 15 cross 10. And then again plot it. Epochs against the loss, and label it like training loss. And again we'll also plot the validation loss to see if they are going hand in hand. They should sync with each other, or else it will indicate. If it not, it will indicate that something is fishy. Legend to both training and validation plots. Show. And now let's predict from the data that we actually stored before. Like we'll make a prediction and then validate how we have performed. Model. Prediction model dot prediction data that we have stored before, the first value in the training data set, and then we'll actually print out the expected and the prediction result. I store it in result, and then prediction result. Prediction, let's run it and see the graph. Okay, see if you can see, it's very nice, and you can see that graph is curved down, and yeah, and 70.71 is expected, but we have our model has given 0.64. It's not bad, very good, right? You can further improve on this. Yeah, this is it, guys. Hope you enjoyed it, and I'll keep doing more videos like this. Thank you.